So in this section we're going to go over how phase change and heat are related to one another. In the last video we looked at one of the specific equations, looking at how heat is regulated by specific heat and the change in temperature. The next two equations we're going to look at, and again these can be found on the last page of your reference table. The next two that we're going to look at today are this one and this one. So just take a quick look at them. Q is still going to equal the heat, M is still for mass, but we have two items here, H of F, which stands for heat of fusion, and H of V, subscript V, meaning vaporization. So you need to be able to identify what those two variables are, and you can find that on page 1 of your reference table. Okay, so write it in now. Heat of fusion would be H subscript F, and heat of vaporization would be H subscript V. All right, so let's go back to our notes. Other equations again from table T, but also keep in mind you need to look at table wherever we were. All right, so when do you use these equations? Again, it's good to notice, well, what is vaporization and what is fusion? So let me tell you what the words mean. So we can write fusion. We've seen this in nuclear chemistry. Kind of putting together. Okay, so let's just say coming together. Okay. However, when it comes to the phase change diagram, fusion is going to be this spot right here. Okay. So fusion, coming together between a solid and or a liquid. Okay. Let's take a look at the other term, vaporization. Okay. Vapors, we know, are gases. So this is going to be the phase change between a liquid becoming a gas or vice versa. So that's going to be this part of the phase change diagram. Okay. So when we're looking at phase changes and the next two equations, temperature doesn't matter. There is no change in temperature. So for the one that is melting and freezing, which I will tell you is this. Oops, let me go the right way. Melting. You can see that this is a solid, right? So that solid is going to eventually become a liquid. Just write an L there. And we also know when a liquid becomes a solid, we call that freezing. So for that, we pay attention to the Q equals mass times the H of F, which is the heat of fusion. Okay. We know that solid, when you add heat, it becomes a liquid. So melting, or the word that we're using here, is now fusion. So let's update the definition. We know that fusion, I'm down here, meant for a long time coming together. But when we're talking about phase change, we're talking about melting. Okay. A liquid can become a gas. Okay. What did we say that was? Liquid becoming a gas. This is called vaporization. So we can update our definition as boiling or vaporization. Okay. And if we go directly from a solid to a gas, this is what we call sublimation. We see this with iodine particles. If you ever take a look at solid iodine in a bottle and there's a nice little label on it, that label looks like it has the color of iodine on it because it's vaporizing and subliming into a gas that's adhering to the paper. So pretty cool things. Okay. So when we're talking about boiling or condensing, boiling would be going from a liquid to a gas. So let's put that in there. If we were taking a gas and making it into a liquid, that would be called condensing or condensation. Okay. We would use the Q equals mass times H of V, the heat of vaporization. And we can see that when it's becoming a liquid to a gas, this you don't have to worry about for all intensive purposes. Sublimation would be going from here to here, and we're not really going to pay attention to that in high school chemistry. So when we are doing these activities, when we are going in the direction of this way, I'll just go up here. I'm going to write it in kind of a magenta. Yeah, so I should do it. Oh, I'll do it in a red. What we're doing here is we're adding heat energy. So anytime we are adding heat energy, see the heat? When we add it, it's considered a reactant, therefore it's going to be an endothermic reaction. And again, if you want to take from the delta H conversation, that delta H would be positive. Okay. Exothermic, and let's just pick an arbitrary number. Let's see. Exothermic would be going in the other direction. So let's go over this briefly, what it's going to look like. If I go from a liquid to a solid, that's going to be here, so that's fusion. You can say freezing too, same thing. If you're going from a gas to a liquid, that would be gas, liquid. Vaporization. Well, technically not vaporization. Gas to a liquid would be condensation. And if we go from a gas to a solid, we can see this when there's a quick drop in temperature and all of a sudden there's like ice on your windows. That would be called deposition, which is a earth science term. Okay, so a quick note about that. We were going in this direction. So gas to a liquid, gas to a solid, all of this exothermic, meaning in that case, that is going to be a negative delta H on table I. Okay. So what I'd like you to do is I'd like you to practice these two examples. Okay. When you get into school, I'd like to see your notes.